Right, so in this video I'm going to have a look at the Leaving Certificate Higher Level Paper 1 for 2018, and I'm going to have a look at question 1. So in part A here it involves solving this simultaneous equation here with three unknowns, x, y and z. I've labelled the three equations here 1, 2 and 3. Now if you look at these three equations here, you've got two equations with x, y and z, and you've got one equation with just x and z. So probably the best thing to do here, a number of ways of approaching this, but probably the best thing to do here is take the first two equations and try and eliminate y. So that'll give us a fourth equation with just x and z in it, and I can put that equation together with this equation 3 here to solve for either x or z. So that's what I'm going to do. So I'm just going to take equations 1 and 2 first. So let's take equation 1, which is 2x plus 3y minus z equals minus 4. That's equation 1. Now let's take equation 2 then. That's 3x plus 2y plus 2z, and that's equal to 14. That's equation 2. Now I'm going to put these two together. I'm going to try to eliminate y. So what I need to do really is look at the lowest common multiple here of 2 and 3. So that's going to be, I'm going to multiply equation 1 by 2 and equation 2 by 3. So that'll give me a 6. Lowest common multiple of 2 and 3 is 6. So I'm going to take equation 1 and I'm going to multiply by, let's say, 2. So let's see what we get when we do that. So when I multiply by 2, I should get 4x plus 6y minus 2z, and that's going to be equal to minus 8. Okay, so let's take equation 2 then, and I'm going to multiply that by 3, but I want the signs to be different as well, so I need this to be negative. So I'm going to multiply by minus 3. So let's do that. Let's see. So we're going to multiply this by minus 3. That gives me minus 9x. Multiply this by minus 3. That will give me minus 6y. That's exactly what I want. I have a plus 6y and a minus 6y here. Multiply this one here by minus 3. That will give me minus 6z. And finally multiply this by minus 3 here, and that gives me minus 42. Okay, so let's do that then. We're going to put these two together then and add them. So if I add minus 9x plus 4x, that'll give me minus 5x. Plus 6y minus 6y will give me 0. That's exactly what I wanted. And here I have minus 6z minus 2z, so that'll give me minus 8z. And then here we have minus 42 minus 8, that's just minus 50. Okay, so we're going to call this equation number 4. Now I now have an equation here with just x and z in it, and I'm going to put this equation here underneath it, equation number 3. So equation number 3 here was x minus 3z is equal to minus 13. This was equation 3. Okay, so now I need to try and eliminate either the x or the z. Probably the best thing to eliminate here would be the x, because I only have to deal with one equation here. So I'm going to take equation 3 here, and I'm going to multiply it by 5. If I multiply by 5 here, I'll end up with a 5x here and a minus 5x here, which will cancel nicely for me. So multiply this by 5, I'll get 5x. Multiply this by 5 here, I'll end up with minus 15z, and then multiply this here by 5 as well, so that'll give me minus 65. Okay, so now let's just put in our other equation here. So I'm going to put in equation 4 underneath it. So that was minus 5x minus 8z, and we had a minus 50 as well. This is equation number 4. Okay, so let's just add these two now and see what we get. So if we add these two here, I got a plus 5x minus 5x, so that'll give me 0. Here I've got a minus 8z minus 15z, that'll give me a minus 23z. And then over here I have a minus 65 minus 50, so that's minus 115. If I solve for this here, I'll just get z is equal to 5. So now I have one of these solutions that I need. I have a z equal to 5. That's perfect. Now we'll work over here just to keep everything on the one screen here. So let's see, we have z equal to 5. So let's pick one. We can pick any of these equations here and just solve for x. So let's take equation number 3, let's say. Where's equation number 3? Here it is here. So let's take equation number 3. That was x minus 3z is equal to minus 13. Okay, so this is equation number 3. I now know what z is. I know z is 5, so I can just substitute it in here. So that'll give me x minus 3 times 5 is equal to minus 13. So that just gives me x minus 15 is equal to minus 13. That just gives me x is equal to 2. So now I've got x and I've got a z here. So this is my second solution here. Okay, so one more to go then. I need to solve for, we have x, we have z, I need to solve for y here. So let's pick equation number 1. So equation number 1 was 2x plus 3y minus z is equal to minus 4. This is equation number 1 here. Let's substitute in everything that we know. So we have 2 times x, well x is 2. We have plus 3y, y we've got to find out. Z is 5, so I'm going to put 5 in here, and it's minus 4 on this side. So solve this then. So you've got 4 here, you've got plus 3y, you've got a minus 5 here, and you've got minus 4 here. So that'll give me 3y. Well, 4 minus 5 is just minus 1 is equal to minus 4. So that gives me 3y minus 1 is equal to minus 4. So that will give me, let's see, 3y is equal to minus 3. And finally then that will just give me, let me see here, so we just have y is equal to minus 1. So that's the, let's just put that in blue here to keep it all the same. So we've got y is equal to minus 1. So there are 3 solutions. So we've got, if we write them all out, we have x is 2, we have y is minus 1, and we have z is 5. So there are our solutions then. This is our answer here, if you like. Okay, so that's part 1. Or part A even. Let's move down here. I think I have the second part here somewhere. So we have to solve this inequality. Solve this inequality here. So we have 2x minus 3 divided by x plus 2. This is greater than or equal to 3. And we know that x is real and x can't be equal to minus 2, because that would give us a 0 as our denominator here. So we can't divide by 0. Okay, so when you're doing these type of questions, what you've got to remember here is that on the bottom here you've got, as our denominator here, we have an x plus 2. Now normally to get rid of fractions, to get rid of our denominator here, we'd multiply across by our denominator. But the problem with this is we don't know what x is. We haven't solved this yet. We don't know what x is. X could make the denominator negative. So for example, if x was, for example, minus 5, that would give us our denominator here as minus 3. If I multiply across by minus 3, that means I would have to flip this inequality sign around. But I don't know what x is, so I can't just simply multiply across by x plus 2, because I don't know that x plus 2 is positive or negative. So I need to multiply across by something that's positive, that I know is positive or at least equal to 0. So what I'm going to do is multiply across by x plus 2 squared. So, and that will work for us. I'm going to multiply across by x plus 2 squared. Now, so I'm going to multiply the left hand side by x plus 2 squared, and I'm going to multiply the right hand side by x plus 2 squared. Now I know that what I'm multiplying across by is certainly not negative, so I don't have to worry about flipping this sign around. I know it has to remain like this. So let's just do this and see what happens. Well, this x plus 2 here will divide into one of these, and I'll just end up with x plus 2 times 2x minus 3. And on the right hand side I'll end up with 3 times, if I multiply this here out, I'll get x squared plus 4x plus 4. Okay, so let's do the next line then. We've got, multiply this out here, so we've got 2x squared, we've got minus 3x, we've got these two here, which is plus 4x, and then finally we've got plus times minus, which is minus. 2 times 3 is 6. Now let's multiply this out. We've got 3x squared, we've got 12x, and we have 3 4s 12. Now let me just simplify this a little bit. We've got 2x squared, we've got minus 3x plus 4x, that'll give me a plus x. We've got a minus 6, and on this side we don't have to do anything. 3x squared plus 12x plus 12. Okay, so let's just bring everything over to one side. So what I'm going to do here is, I've got a 3x squared here, I've got a 2x squared here, so I'm going to bring everything over to the right hand side, just keep everything positive. So 3x squared minus 2x squared will give me x squared, plus 12x minus x will give me plus 11x, plus 12 plus 6 will give me plus 18. Right, so now I've reduced this inequality down to its as much as I can. I've simplified it as much as I can. So I've got to solve this inequality here, which is exactly the same as solving our original inequality. It's the same thing really. So how do we go about this? Well, the first thing we do is we want to find the roots of this if this was equal to 0. So in other words, we've got to find where this function here crosses the x-axis. So what we're going to do is just find the roots first. I'm going to let x squared plus 11x plus 18 equal to 0 first. Now this was not what we were asked to solve, but it's just a step on the way to solving what we were asked to solve. So let's just solve this, and we get an x times x here. Here we want to get an 11 and an 18. Let's see, when we multiply, well, we have 3 6's will give us 18, but a 6 and a 3 won't give us 11. We have 9 and 2 will give us 11. So I'll put the 9 here, the 2 here. It happens to be a plus and a plus here, so that's handy. So we just have plus here. So that will give me x plus 9 equal to 0, which means x is equal to minus 9. And we have x plus 2 equal to 0. That means x will be equal to minus 2. So what does that mean? So when we, if we were to plot that, it will look something like this. It'll look something like this. It's a quadratic, it's a positive x squared, so it's a U shape, and we have our two roots. We know that it crosses the x-axis here at minus 9 0, and here this one here is going to be minus 2 0. So this here is going to be minus 2 0, this point here. Now, what were we actually asked to solve? This is what we were actually asked to solve here, this particular inequality here. This is a version of our original inequality. So what do we want? We want the right hand side here to be less than or equal to 0. Less than or equal to 0. So we want y, excuse me, y to be less than or equal to 0. So it can be equal to 0, so we're looking at this point here and this point here. We want it to be less than or equal to 0. Well, all these points here have y coordinates that are less than or equal to 0. So we want all of these points here on our graph. But what the question actually asks us to solve this inequality, which means we got to find what x is. We got to find the range of values of x that gives us these points here. Well, the x values that gives us those points there are these x values here, including this one and including this one here. Now, so really our solution is, at first glance anyway, our solution is x has to be greater than or equal to -9, and it has to be less than or equal to -2. So really this is our solution here. However, if you look back at the original question, you always go back and read the question. When you have your answer written down, go back and read the question again, just to be sure you have your answer written the way they want you to write it, or it might give you some extra bit of information, as it does here, that will cause you to kind of adjust your answer, if you like. And the extra bit of information here you were given was that x cannot be equal to -2. X is not equal to -2, so we can't have less than or equal to -2 here. So our actual answer then, our actual answer here is going to be x is greater than or equal to -9 and less than -2. So really our graph here would involve something like this. We would just kind of draw a circle here that we wouldn't fill out. So we'd have a circle drawn here at -2. Don't kind of color this in, don't fill it in here. This one here we can fill in because it can be equal to -9, but it's not equal to -2. Okay, so that's it for question 1.